Welcome to today's webinar on trends in software supply chain security. Before we get started, we're going to do a little bit of housekeeping. As you've probably noticed, your lines are muted, but you will be able to ask questions. So there is a question panel on your GoToWebinar control panel. So feel free to put in questions at any point in time. We may be able to take some along the way, but if not, we'll pick them up at the end and answer any questions you might have. Also, one of the common questions that we do get is, how do we get a copy of the slides? So you will be receiving a follow-up email with a link to be able to get that recording with the slides. Also, we'll provide you with a link at the end to actually download the software supply chain security report, which is where these stats are coming from. We'll be just highlighting some of the stats today, but you can get the full list by downloading that report. And then when you leave the webinar, there will be an opportunity to take just a quick 3-question feedback survey. So we really appreciate that. If you can fill that out, then we get feedback about what works and what doesn't and can improve on future webinars. So my name is Kim Wines. I'm head of the marketing organization here at Anchore. And today I have with me Dan Nurmi, who's our CTO and co-founder. So he's going to be providing some color commentary on the data that you're going to be seeing as we go through the results from the survey and from the report.
Good morning, everyone. Thank you for attending.
So here's kind of the high-level agenda, some of the key things that we're going to be talking about. I'm going to give you a sense of who is in the survey, because I think that's really important to understand the results. And then here are some of the topics that we'll be covering as we go through the report. So before we get into the actual data, I thought I'd turn it over to Dan to maybe talk a little bit about why are we even focused on software supply chain security?
Yes, thank you very much, Kim. So this is an interesting topic and something that's very relevant given the number of security incidents that we've seen in the news over the last 6 or so months, or even shorter than that, that have had quite a bit of visibility. And a lot of times what we're seeing in the reports is the terms supply chain and software supply chain attacks, and supply chain has been compromised, those kind of phrases. And so we thought we'd take a look at, asking the question, what exactly is going on? What are malicious actors and hackers seeing that result in some of these successful software supply chain attacks? And that leads us to answer the question, why do we care and what can we do about it? So what we're looking at here is sort of a high-level depiction of what a somewhat typical modern software development machinery and process kind of looks like. So over on the left-hand side, we've got the elements that your developers are working on. This is source code. They're writing applications. They're making new features and doing bug fixes and security updates and that kind of stuff, all in source code. Then way over on the right, ultimately we have that source code gets turned into things that we publish for our customers to download. Right, this would be in the case where we're a software supplier, or maybe you run it. Right, so you're an internal team that's got developers writing internal tools, or your company is providing a SaaS or something like this, and your application gets actually executed. In between, we've got all these steps for the actual development process, the build process, testing all of that new code in form of the executables that have been generated for functionality and other characteristics. Sometimes we stage the application for sort of final functional testing and regression testing, things like that, and then finally it's ready to go out in production. That's the workload. And we also have the platforms, right? So this is kind of the development infrastructure that facilitates all of these pipelines, right? Turning the source code into executables, deploying the executables for testing and staging, and then finally publication. So we kind of differentiate and show this is practically, what a system like this looks like, and it's constantly running in a cycle, in a loop. So oftentimes in modern systems, these are highly automated. And so now when a malicious actor or hacker looks at that, this looks like an opportunity, right, to come in and say, if I can compromise any of these elements, then I can get my malicious code, my attack, my software vulnerability, my exploiting human error into this process. Ultimately, that can lead to, at the end of this cycle, whatever's published and run is exploitable. Right, so at a very high level, that's essentially what we're looking at, and what's the root cause of a lot of supply chain attacks.
Great, thanks, Dan. So with that context, let's just talk about the report. So this report is based on a survey of larger enterprises, over 1,000 employees in size, and really focused on sort of leaders within those enterprises, whether executive level, VP level, or manager, director level. So we'll be going through a little bit of those demographics in a moment. The one thing is we do actually encourage sharing of the data. So all of the charts and data in the report are licensed under a Creative Commons open source license. And the only requirement is that if you copy or redistribute or create your own charts off the materials, if you can just provide attribution to the source coming from the Anchore 2021 Software Supply Chain Security Report, that would be great, but we do encourage reuse and sharing. All right, so let's talk about our audience, who we surveyed. So first to note, this was 425 respondents. And as we said, we focused it on only organizations with more than 1,000 employees because we really wanted to get the enterprise view of this. We do see a lot of surveys out there that focus on talking to developers or open source communities, which is great to get that perspective, but often they are limited in understanding what larger enterprises are doing. And so this is the breakdown with about half of the respondents being in the higher end side of that, with having more than 5,000 employees. The second to note is the data source that we used for this, the panel that we used is vetted. So we do know that everybody responds, they work for the company they say they work for, and they have the title and the role that they say they do. So that's really nice to have the high quality of data. And you can see about half of the respondents were either at C level or VP level, while the other half were other levels of management, whether director, manager, or architect. So these are people that have visibility across typically, multiple projects. And then in terms of the functions that they come from, it really is a combination of, just general IT roles, security roles, DevOps roles, development roles, and some others. So really focusing on the people that do have a view of what's going on in terms of their supply chain security. On the industry side, it was a mix of industries. You can see software being the largest at 18%, but 15% in financial services. So these are people that generally do a lot of software development. And then on through a variety of other industries. Anything that's not listed here would fall under the other category. So these were industries where the respondents was like 3% or less of the respondent pool. And then from a regional perspective, we did focus on North America and Europe. So we did not include Asia in this particular survey. And it was about just under 3/4 North America and the rest being Europe, both a combination, the United Kingdom being pretty heavily weighted there. All right, so let's get into some of the data and see what that's telling us. So the first thing we asked, just to get a sense of the audience, is what their maturity was in using containers. And we wanted to focus on containers because as we move into sort of the modern development world, those are being very heavily used, especially for greenfield development, but even with many people as they're migrating to the cloud. And we really had kind of that cloud native focus in this survey. And so we asked them how many of their applications they were running in containers, and you can see the breakdown here, and we kind of grouped them into sort of beginner, intermediate, and advanced, or just starting out. And so what was interesting here is that we did have quite a number of people in both the intermediate and advanced phase. And so this is across a variety of industries, and so we are seeing fairly significant adoption of containers across those industries. Then we did, to follow that up, a breakout by industry to see what that looked like. And you can see at the top of the list, so the darker blue here, the bigger those bars are, then the more advanced users we had. And then, you can see the medium, the lighter blue down to the gray. So the top industries for adoption are probably not very surprisingly cloud service providers and software and SaaS companies who are often on the leading edge. but then you can see some of the other, non-tech industries also have fairly significant adoption of containers.
Mhm.
So I'm curious, Dan, is this seem surprising to you? Does this compare well to what you've seen out there as you're talking to customers and companies?
Yeah, it actually does a little bit. I mean, certainly the idea of the cloud service providers, the SaaS providers, technology providers being a little bit further along, is I think a typical trend for something like adoption of containers. But especially in the sense that containers really are appropriate for systems that are ready for really a high degree of automation, a lot of dynamic application development processes and things like that. It is a little surprising to me, honestly, to see that there is such significant adoption across some of the non-technical industries. I know that containers are the kind of thing that are certainly have been making their way into industries across the board, but this is a really exciting value to show that everybody is looking at more automation, faster development to production cycles across all of these industries.
Yeah, it's great to see it's not just the highly technical folks or the highly technical organizations, let's say.
Mm-hmm.
Now, we also asked about planned change in container use in the next 24 months, and probably to nobody's surprise, people are going to be using more. So this trend is only going to increase. So as we repeat the survey next year, what we'll probably expect to see is more people moving into those advanced and intermediate buckets over time, with 29% planning to do significant increase in their use of containers. Now, we also wanted to understand what types of apps people were putting in containers. Is this really just things that are being shipped or other types of things? And interestingly, tied for first place was the customer-facing apps and the employee-facing apps. And customer-facing doesn't necessarily mean just applications you ship, right? You could be, a retail organization, which we saw on the previous list, and you've done something with your website or on your website or shopping or whatever it is. That's a customer-facing application that you're leveraging containers for. And then, of course, we see things that are more the shippable types of things, where you're producing software for one or multiple other people, or a SaaS product for multiple other people. All right, so let's talk about container risk. So we were curious to see, from a security perspective, do organizations using containers think that they're higher risk or lower risk? And so here you can see the red are people that thought they were higher risk, and the lower risk is the green, and the gray says it's about the same. So really my takeaway here is it was fairly balanced. There was slightly more that said it was significantly lower risk than significantly higher risk, but fairly balanced of, it's about the same, or people believe one or the other almost equally. So we decided to break this down into a little bit more detail, and this is where it's got interesting, which is we looked at their maturity level, whether they were kind of at the beginner, intermediate, or advanced phases of their container adoption. So that was one of the earlier questions we had asked. And then we looked at what their perceived risk was. And so here what you can see is as you move up these bars to more advanced maturity, the red gets bigger. And this was interesting to me. I've been in the cloud space now for about 12, 13 years. And in the cloud space, we saw the opposite happen. We saw that as people were early in their phase of adopting cloud, they were really concerned about security, and they felt that that was really a big issue. The risk perception was very high. But then as they got more mature in their cloud use and they became aware of what the best practices were and all the opportunities and tools and services from the cloud providers to be able to secure their applications, their perception of the risk went down. So this is a reverse approach, right? It's almost counterintuitive. So I'm curious, Dan, why do you think container users, as they get more advanced, are thinking, no, this is riskier?
Yeah, I mean, I agree. This is a very interesting result, and something that, I think we're going to dig into further with, perhaps future surveys. We can start to explore this particular aspect in a bit more detail. But for now, we do have some ideas as to why this might be. And one of the most, I think, sensible ways of looking at this is that with containers, it's a new data element, and importantly, unlike cloud in general, containers actually will, in many cases, bring new software elements into the development pipeline, right? And that's something that I don't think when you're starting out with containers, I think it's possible that a lot of organizations think of containers as, it's a lightweight virtual machine. It's kind of like cloud computing. It's the same kind of thing, but it turns out a lot of the processes around containers are very different. They allow sometimes developers to share containers or pull base containers from other sources online, like Docker Hub and other container registries, mix and match them. The provenance can be all over the place. The rapid development cycles means that there's a lot of different builds happening. Like, within 5 minutes, you can have a completely different base image since we're getting new software installed in it. And some of that software is not directly associated with the software, application code itself. And so I think the further we kind of look into these new data elements and realize that there's actually more software in there, more things that have to be looked at. By default, you can't really tell that. Containers are a little bit of a black box, but when you start to understand how they're composed, then suddenly you realize there's actually more things happening. This is a new thing that we have to look at, new software sources, new software versions that we have to be attended to from the perspective of security. And so I think the more you understand, the more you realize there's more to be done.
Makes sense. And also there's all those dependencies, right? The pesky dependencies. This container is dependent on other things that are dependent on other things, which may pull in more stuff than you originally anticipated.
That's right.
All right, so let's keep going and let's talk about the focus. Let's move from just pure containers and talk about the software supply chain, right? And what are enterprises doing there? So the first thing we wanted to do is, are people actually being impacted by all these software supply chain attacks that have happened? And we did this survey in April of this year, so it's fairly recent. And of course, some of those attacks did start happening in the first quarter. And so we asked them if they were affected by it, whether they thought there was a significant impact, a moderate impact, or a minor impact on their organization versus not impacted. So here we see 64%, so almost 2/3, were affected in some way by a software supply chain attack in the last 12 months. And over 1/3 felt that they had a moderate or significant impact. So what do you think that means to these organizations? What does a moderate or significant impact look like, Dan?
Yeah, I mean, I generally there's kind of two different interpretations of impact that I think respondents might have been thinking about when it comes to significant or moderate. Significant to me implies that really there was a supply chain attack, there was an actual exploit, it was in the wild, and your organization was actually exploited, right? It was verified, you've been hacked, right? That absolutely falls into the significant impact category. But there's other ways of thinking about significant impact, right? Some of the supply chain attacks over the last year have been of the form where it's actually a little bit difficult to prove whether or not you've been exploited, even though it is possible to prove that your software was vulnerable for a certain amount of time. And that can result in a significant impact as well, because if you don't know, then essentially, oftentimes a larger organization that's serious about security will do a full audit. You have to go through and verify everything, look at all your data sources, look at logs, go through a really serious review that's almost the same in terms of severity and cost of what would happen if you'd actually been exploited, and that was proven. I think in the moderate impact, it's usually the case that an exploit hasn't been explicitly proven, but you've done some kind of, we're not quite sure, we need to go do a security audit. And so we know that we had some vulnerable software for sure, running, but say it was off the network, or it had limited scope, that kind of thing. But it still means that your organization had to go through a review and a software audit. So that's typically what I think those categories imply.
Yeah, that makes sense, because sometimes even if you haven't been impacted, if there's vulnerability, just the work of remediating can be, at least a moderate impact. It can take a lot of time and effort to do that.
Yeah.
All right, so how is this impacting organizations? So based on these attacks, are they focusing on securing the software supply chain? And so I think the answer is yeah. So we asked, like, how high of a focus was it for their organization? You can see 14% said it was a top area of focus. Another about half said significant, and then the remainder said somewhat, and a few were just starting to pay attention or not a priority. So should this be higher? Should more people be paying attention than are?
Yeah, that's an interesting question, Kim. I think this graph, I think, is reasonable given when the survey went out, and what sort of respondents, larger enterprise organizations we've been polling. Given that, like we'd been saying all along, there have been some really significant, very public supply chain attacks that came out that were serious. They affected a lot of organizations, even up into the U.S. federal government, right? So these things were really serious. And security, just in our experience, trends and investment in security concern, like focusing on security, is something that kind of goes in a sine wave, right? And definitely when there's new technologies, sometimes security isn't really kind of the focus of a lot of organizations, even though functionality is. We're trying to adopt modern SDLC and software development systems. We're pulling in containers, trying to get everything to work. Malicious actors will come in and, like I was saying earlier, see this as potential weakness because there's new systems. They come in, very public security incidents happen, and then the industry starts to focus on security quite substantially for a while, until the industry at large is confident that the new technology is secured adequately, and all of the sort of holes are plugged for now. And then it kind of swings back down again. Unfortunately, we kind of see security move up and down like that when it comes to focus and investment.
Well, so this one we also broke down by maturity, like we did with the other question where we asked about concerns about container risks. And this one kind of followed more what I would have expected, which is the more mature you are, then the more you're focusing on supply chain. So maybe these go hand in hand, right? As you start to use container more, you see there's increased risk, and so therefore you start to focus more on securing the software supply chain.
That's right.
All right, let's keep moving along. So then we just asked them what were their top initiatives with containers specifically through 2022. And the first was use more containers, and then the second was improve the security. So not probably too surprising, but those went hand in hand. And then you can see some of the other items here. One thing I wanted to highlight, and Dan, this is something you've talked about before, like down at the bottom of the list was improving the security of the DevOps toolchain. And in your first slide, when you talked about why care about supply chain security, I noticed there were little red X's of attacks that happen like at the actual toolchain itself. And that's how you then get into the code or into the application. So is this something where people are just sort of lagging and realizing that that's a threat vector?
It's a good question. I don't think people are unaware generally, right? Because the teams and organizations who are operating these systems understand what they do.
Right.
But security is really tricky because it's oftentimes the vectors for how something can get into what you feel you have good control over and understand the access patterns to can be really, really difficult to unearth. And it's what malicious actors and hackers are really good at. But at the same time, I do think that the increased reliance on automation might actually be more around the sort of new focus on this kind of these types of systems. Because it used to be that you'd have some human beings like really in operating, configuring, understanding a lot, but that's not really feasible for very much longer. So these systems are going to be highly automated, and that's also a little bit scary from a security perspective because no one's there to notice necessarily. We have to make sure that our tooling and security auditing tools are automation aware and can actually be there and be better at actually looking for security problems and malicious actors and anomalies than humans can be, given the amount of data and workload that are being pumped through these systems.
Great, thanks for that comment. All right, so how are people doing? They're going to focus on it. We heard that. How are they actually doing and securing the software supply chain? So we asked a few questions to provide some insight into that. So the first thing we did is we asked specifically what are their top container security challenges, and we asked them to stack rank them. So the green here, or the first kind of bar, if you're not colorblind, but the first part of the bar, the green, is people that ranked it as number 1. The second is they ranked it as number 2. The third is as number 3. And so I've kind of sorted these based on who ranked it as number 1. And so, they're kind of concerned about both the security of the open source containers they're consuming, which we'll talk about a little more in a moment, and the security of the code that they write. But then it was interesting to me that the third most ranked first was understanding the full SBOM, software bill of materials. And so that kind of, it's kind of this SBOM is a bit of a new concept for people. Why do you think that ranked so highly in this survey?
Yeah, I mean, it was a little again a little surprising to us, but not from a perspective from where we come from necessarily at Anchore. We've been looking at software bill of materials as a primary, really important element of this story for a while, and the reason is that one thing we were talking about earlier is that containers are a little bit of a hidden artifact where there's it's very good. A container is very good at some aspects of being portable. It's an entire execution environment sometimes with configuration and data in it. You can run it anywhere. It has a name that's given to it by a human being or say a CI/CD system, but what's actually inside of that container can vary substantially from one tiny little binary to a full-fledged operating system with a vendor piece of software that's got tens of thousands of open source dependencies and maybe even other vendor dependencies all within this one container image. It just has a name and you run it, right? So I think as one of the charts we had earlier that was showing that as folks are getting more advanced with their container usage, they're getting more concerned about security of containers. One of those aspects comes down to, well, if we had full, reliable, comprehensive software bill of materials for all of our container situations, ranging from running things to things that we're producing to things that we're consuming as an organization, we'd be in a better position because we can't really detect or scan or reason about what's going on with our software surface area until we have a bill of materials. And so I think that's where these two pieces of information relate.
All right, let's keep going. I wanted to talk a little bit about open source. So one of the things that we asked people was across all their containerized applications, where do they estimate is the source of that code? Is it something they developed internally? Did it come from open source, commercial off the shelf, third party, or government in the case of government organizations? So this one really surprised me because we've all seen the data from, Synopsys does their open source software risk analysis annual report where they take the data from actual code bases that they've scanned over the prior year, and they provide some stats about what percentage of that code is open source code. And it ranges a bit by industry, but generally it's between 50 and 80 or 90%, kind of averaging in the 70% range. So based on those scans, 70%-ish of code is open source. Yet people in this survey said, hey, it's only 26% open source. So why is there that disconnect?
Yeah, this one I think is probably a little bit more subtle, definitely worth digging into further. But my understanding of this kind of information is that, well, at the end of the day, commercial off the shelf these days will come with a lot of open source. It might just not be apparent, right? So as an organization consuming software, you might have bought a database or a web application or any application that's being delivered in the form of containers commercially from some vendor. And if it comes into your organization as a container without actually looking into it deeply, and sometimes it's really hard to do that, you don't really know. It's one thing, right? You bought software X from vendor Y, but it turns out software X, as we all know, will these days almost surely be reliant on any number of other software packages from other vendors or from open source projects. So really, it's not so much about open source or not open source. It's back to that full software bill of materials, and I think people are starting to understand, whether or not it's open source or not, software is a composition of lots of different software elements that come from various organizations. We need to be able to understand and track this information a bit more.
Makes sense. It looks like one thing on the surface. You got it from some third party or commercially, but under the covers, there's some hidden surprises.
Mm-hmm.
All right, so let's keep moving. So then we wanted to focus on what people are doing for software supply chain practices. What have they actually implemented? And you can see that it wasn't like amazing to see that like at the high end, some of these practices was half the time. So I guess that's better than none, but it's only half. So scanning third-party containers or open source containers, only half the people are doing that, which is a bit scary. Private repos, looking at having private repos for dependencies. So one of the types of attacks we've seen is kind of dependency squatting, meaning your code is dependent on another container. That container is in a public repo, and they squat on a typo for that container, put in some malicious code. Your code pulls that down because somebody put a typo in, and now all of a sudden you have an issue. And then you can see on down the line, but specifically, we talked about SBOMs just a moment ago. Only a quarter of people are either requiring an SBOM from their software suppliers, not to mention, of course, open source, or producing an SBOM for their containers. So that says that people are starting to say, hey, SBOM is important, it's something we need to do, but maybe not doing it yet. So the other thing we wanted to ask about specifically on the DevOps toolchain, which we talked about a little bit earlier, is one of the mechanisms, certainly not the only, to securing that toolchain is using infrastructure as code. Again, we're seeing about half the people implementing infrastructure as code for that DevOps toolchain. So why would somebody want to be thinking about infrastructure as code to secure these applications in their toolchain?
Yeah, I think there's a couple reasons, but probably the most sort of prevalent is just the fact that infrastructure as code techniques have a lot of value when it comes to managing your infrastructure. And again, we're starting to move towards a world where there's a lot of automation, automatic deployment, even of your infrastructure itself. And so being able to closely manage your infrastructure's configurations and deployment using infrastructure as code techniques is very useful functionally. But in addition, there's this whole notion of change control. And again, this kind of goes back to what malicious actors and attackers look for. They look for weaknesses. And a common weakness can be human error, right? The number of times that a piece of infrastructure has a default password that just wasn't changed from the default, and that leads to attackers being able to get into a system and wreak havoc is insane. Like, it happens all the time. It continues to happen. With infrastructure as code techniques, those kind of things are much less likely to happen. You have more control over the change control for your infrastructure's configurations. And so I think there's a natural, way to say, if we're using infrastructure as code, we can have a better security posture for this infrastructure, since we have better control over all of the deployment and configuration steps that happen, especially when changes occur.
All right, so you heard it here, folks. If you're not doing infrastructure as code for your DevOps toolchain, maybe time to start. All right, so what are the challenges organizations are facing as they're trying to scan containers? And so one of the first things that we wanted to understand is what compliance standards people are following. And you can see here they're kind of stacked rank. And of course, depending on your industry, there's certain ones that are going to be more relevant. But right at the top of the list was the CIS benchmarks. And these are the Docker benchmarks that people might be familiar with. So that was really interesting to me that that one was at the top of the list. Why did that rank so highly?
Yeah, I think probably the most compelling reason to think about that is that some of these other compliance standards will reference, have and do reference some foundational benchmarks or compliance standards as sufficient, right? So and in particular, when they look at certain aspects of the infrastructure, PCI and HIPAA are very comprehensive. They cover a lot of ground very broadly across different processes and organizational elements. But when it comes to things like your software development pipeline or your IT environment, they might reference CIS benchmark ABC or NIST standards XYZ actually are sufficient to comply with what we're talking about in that part of your organization, right? So there are there's a hierarchy in a sense for some of your organizational elements, and CIS and NIST are in that category. Now, why CIS is so much higher than NIST, it's a little bit speculation, but I will say, CIS was definitely, proactive when it comes to publishing information about container and Docker and Kubernetes specific compliance controls very early on, which might explain why it's so high on this list.
Okay, yeah, that makes a lot of sense. All right, let's look at some of the practices to see what practices they're using. So again, we asked them about scanning source code written by their developers, scanning source code for open source dependencies, scanning images in production. So here we got a little bit higher numbers in terms of people that are implementing these scanning practices, but still I would say some room for improvement in some of these areas, but definitely making progress. In terms of the container scanning challenges, the top challenge was in identifying vulnerabilities in containers. And then you can see, and we have some other identifying malware, identifying secrets a little bit further down the list. But you have like number 2, 3, and 4 here are really about the remediation aspects, right? Like, how do we get developers to remediate what we found? How do we avoid false positives? How do we speed the remediation process? So I'm curious if you have any thoughts on why these developer issues have bubbled up highly.
Yeah, I mean, this one to me feels a little bit more typical when we look at other security practices, prior to containers, and it's starting to feel a little bit more familiar from a very high level, almost abstract level. We need to be able to first identify and understand, what our environment looks like and what's going on, and then second, we need to be able to do something about it in an efficient way. And essentially, these answers, I think, are encoding those, the actions in those two different categories. So identifying vulnerabilities in containers, this kind of goes back to the need for a full SBOM. You need that in order to get vulnerabilities for all of your containers. Identifying malware and secrets, those kind of get to the point that containers can have more than just your application in it. They can have all sorts of data, and malware can affect anything. Identifying vulnerabilities with fixes is actually really interesting. That's like a specific thing, and it's something that some of the more advanced tools, like what we produce in Anchore and others, will be able to report now. And then there's the, in particular, being efficient about responding. And this, in my mind, actually leads to organizations and folks like what we're doing here at Anchore to think really closely about how do we actually make this process more efficient? Not just to make it possible. I think we're past that. Now we have to actually make it really efficient, and that means the data has to be really high quality. Wasting time on false positives means you have to put a lot of time and effort into making sure that when you generate a list of vulnerabilities in a container image or anything, that the incidence of false positives is as low as possible, because every single vulnerability must be assessed. So anyone that's a false positive is wasted time. And with containers, since things are moving so quickly, you can quickly get to the point where you just have so many vulnerabilities to review. You don't have that many hours literally in the day. And so it's very important that we keep an eye on the quality of the data and the vulnerability results being produced.
Well, I think that's a great segue to talk about false positives, because one of my favorite quotes I heard from a customer was, it's not that developers hate fixing security issues, they just hate, dealing with the list of irrelevant security issues, i.e. false positives. And so we asked them to estimate the percent of vulnerabilities that are false positives. So obviously this is an estimate, but they estimate that, almost half, 44%, are false positives. So if, developers or security professionals, whoever is responsible for that, are having to kind of research that issue and have that back and forth between the developer and the security team, no, this isn't relevant and here's why, that's not going to feel productive probably to a lot of people.
Mm-hmm.
All right, let's then just talk about the teams involved in this process, because we've talked about that as we've gone along. So we wanted to understand who's doing what in the organization, and gave them kind of a list of who's responsible for whether doing the security checks or insurance compliance, to finding and fixing the issues, to securing the DevOps toolchain. And this is a heat map. So the darker the green, the higher the percentage, meaning the more likely they are to be involved in that activity. And so we see kind of a center of gravity, certainly around the security team, being kind of having responsibility for these in many orgs. We also see some prioritization in the development teams, especially around finding vulnerabilities during development. And then on the DevOps team, around securing the tool chain. So how does this compare to your experience? And, are you seeing anything different, or should DevOps be more involved in other parts of this process?
Yeah, I have to be honest, this was a little surprising to us, to me at least, which is to say, in our experience, and this might be that, we've been working with, large enterprise organizations, pretty early in their container, or aggressive in adopting containers and high degrees of automation in their development processes for a while now. But really, we've actually been working a lot with DevOps teams. I think the DevOps teams were kind of the first teams to come around and really start to be tasked with making production containerized environments a reality. And because of that, right, fixing security issues in container images and detecting security issues, prioritizing maybe not so much, but compliance standards, those things from some of the early adopters of containers, I think, fell into the DevOps team. It's interesting to me to see that that's shifting to the development side, which is compelling, right? I think that's great, right? That there's more developers thinking about security and having the capabilities of actually fixing some of this stuff really falls in line with our shift left notions of trying to move security further and further left and closer to the organizations or teams that can actually fix the issue, is something that we as an industry have been working on for a while.
Yeah, don't wait till the last minute to find the security issues. That never goes well.
Mm-hmm.
All right, so let's just, because we've been talking about DevOps and we've seen kind of some areas where maybe there could be more attention put on securing DevOps, we wanted to understand a little bit about what's going on with DevOps adoption. So first of all, we asked the obligatory question on, how much people are adopting DevOps. And we wanted to know just not, are you adopting DevOps at your organization? Because most of them are, but what percentage of your projects use DevOps, i.e. how deep and broad is it within your organization? And so we can see that, just under half are really at more than half of their software projects are using DevOps. Another 40% are kind of in that middle range, 20 to 50%, and then a smaller percentage in just a smattering of their projects. So I think what we can take from this is not just, DevOps is the future, is today, but it's also making pretty strong inroads across the development teams within an organization. So then we wanted to hone in a little bit on the actual use of CI/CD tools, since that's, of course, one of the critical elements in a DevOps process for most organizations. And we wanted to assess, like, what's the diversity of tools being used in these organizations. And so we asked how they're selecting their CI/CD tools. So a minority, 20%, said that they have one common CI/CD tool used by all of their teams, whereas 28% said it's a free-for-all. Every team can pick their own CI/CD tools. And then we had kind of the other half sort of having some kind of maybe selected a single tool or two tools, but then there's always exceptions to that. So basically this matches, I think, what we've been seeing out there is you don't go into a large organization and they're like, we only use XYZ tool. It's like the answer, having worked in IT for a while, whenever you ask them, what do you use for this particular category of software? The answer is always one of everything. And I think that's what we've seen out there. So we then asked them about the specific tools, and here we broadened it beyond CI/CD to include, some of the other popular tools that are out there. And you can see kind of the stack ranking of these. And on average, the median, rather, number of tools used by an individual organization is 6. So what does that tell us? Why 6?
Yeah, I believe that this is somewhat typical, but it kind of reminds us that specifically the survey was targeting larger enterprise organizations, and I think it's typical within larger organizations to have a variety of DevOps tools, and some of the reasons for that can vary, but some of the more common reasons are that some organizations, they're very large, and they run the organization where each development team is given the capability or the authority to choose whatever DevOps tool and environment is best suited to the objectives of that team. So it's kind of vertical. Some organizations have tried to create central, common standards and ways of doing things, but not all of these things are exactly the same. There are, from minor to substantial differences between things that even at a high level might look like they accomplish the same task. And I do think it actually underscores that enterprise organizations are willing to deal with higher infrastructure complexity in order to get the value of making sure development is fast, streamlined, and efficient. So, if anything, I would sort of pull that out as a speculation from this information.
Keep the code moving as fast as possible is the bottom line here. All right, and then the last piece here before we wrap up was really just to understand the container platforms themselves and understand what people are using. So we asked them, this I always call like the horse race slide, what's happening in the horse race. And so we asked them what different container platforms they might be using. The top one here called Kubernetes standalone, I'm using that term to mean it's not a PaaS service, right? They're not using Kubernetes as part of EKS. Now they could be running it in the cloud, but it's a Kubernetes implementation. So here, obviously, we saw Kubernetes right up there at the top, still being pretty heavily used, but also, pretty strong adoption of many of the cloud-based PaaS services for Kubernetes. I'm curious, do you have any thoughts on why Kubernetes is just right at the top versus people going to using Amazon EKS or ECS or AKS or GKE?
Yeah, I mean, honestly, I think this is really a tribute to the Kubernetes community and quality of Kubernetes itself, which is extremely high. It's very robust. It works well. It does what it's supposed to do pretty efficiently. It's a vibrant community that's constantly moving forward, and I think it really is indication of a pretty substantial success story for open source, especially in the infrastructure space. And honestly, there's so much happening in the Kubernetes ecosystem where the whole project has managed to accomplish a state that's very difficult to accomplish, which is you have a stable foundation that can actually be used in production, and it's been out there. It feels mature at this point in many ways, but at the same time have exciting new things happening pretty much all the time. I mean, and that's kind of the perfect mix for a piece of technology, is to be able to rely on it, but at the same time take advantage of a lot of new innovations going on in the tech space. And I think Kubernetes natively gets you that, whereas some of the implementations in the cloud vendors, they're farther behind, right? And it turns out you don't necessarily need some of that if you can keep up to date with deploying Kubernetes standalone. You can get that stable, but also get new features coming out all the time from the ecosystem. So I would think that explains what we're seeing here in a sense.
I guess if you have like Google as customer number one on a platform before it really becomes fully open source, that's probably a good way to vet it to begin with.
For sure.
Okay, and then the other thing I did want to mention is, for a while, a few years back, you'd hear a lot about, people are using containers, but they're not using them in production. And here you can see the green and the blue, the first two parts of this bar are either people using these platforms in production plus dev or only in production. And you can see a lot of this is production. So, if you're out there thinking people aren't using containers in production, okay, well, you can sort of check that or X that myth off your list of things to think about. Mm-hmm. And then the last question, and by the way, if anybody has any questions, feel free to put them in the question panel because we should have a couple minutes as we wrap up here. But the last one was we asked them about the number of containers running on these platforms, and we gave them kind of broad ranges just to see how big is the footprint that we're talking about. And here we see that, the number running like under 100 containers is pretty large, that last part of the gray bar. But, there is a kind of a significant number that are running 1,000 plus or 500 to 1,000. And also, given that people are running containers across multiple platforms that we saw earlier, which was 5 different platforms, do the math on that, right? If I'm running 500 on this one and 1,000 on that one and 250 there, it sort of adds up to a fairly significant number there. All right, so that's the stats we have to share today. So feel free to download the report. If you go to the Anchore.com website, you'll see kind of right front and center at the top, you can just click the link and get the full report. Feel free to share. We do make these charts all shareable so you can reuse them. And of course, if you're looking to improve your software supply chain security, feel free to reach out to us at Anchore for Contact Us. And so just as a final wrap up, Dan, I'm just curious, is there anything that you would really like to know about the software supply chain that we didn't cover? Like what's the big burning question in your mind that's left that we should be thinking about as we move to the survey next year?
Yep, I think there's a couple things. One thing that I'm really looking into and very interested in when it comes to supply chain security in specifically is that we really have to understand that the supply chain it's called that because it's a chain of software components that eventually end up being executed, say at the end. But what's important to realize is that sometimes that whole chain can exist internally. It's all your own software, even though there's dependencies and things like that, but you have control over it. But practically, some of these bigger events that are going on, there are multiple organizations, up to 100 organizations might be involved in a single supply chain that ultimately ends up being like one piece of software that runs inside of an enterprise organization. And the transmission of information between organizations in a supply chain is, I think, one of the most interesting consequences of the current thinking around how do we improve the supply chain security situation as an industry. I think trying to resolve those cross-organizational, how do we collaborate and have things like proof of secure process, have things like SBOM quality and data elements that are common between organizations and verifiable. There's some really exciting projects out there that are starting up to try to resolve this, and Anchore is one of those companies that's paying really close attention to that aspect as well. So that's what I think is kind of the big topic that'll be being discussed starting now and and definitely over the next year.
All right, thanks so much, Dan, and thanks for joining us today, everybody, and hope to see you at a future webinar.
Thank you.